Hi, I wanted to give you some support on this assignment. It's about the parallax activity. And this is a drawing I can't take credit for. It was so nicely done by a participating teacher that I decided to use it. So let's take a look at what this picture is about. It looks like a lot of lines, but let's look at them. Here is where the Earth is in one position, and we look out at the stars and we see star A and star B, and we draw a line sort of to where we see it. We say, okay, star A is at this angle when the Earth is here and I'm looking at the star, and star B is at this angle. So we draw a line straight through. 6 months later, we take a look at the same stars, and they appear differently in the sky. For example, instead of, just to use left and right, star A appearing to the left, it actually appears sort of off to our right. So we draw a line through star A and a line through star B. And here's what we do. We say, okay, when I was over here, star A appeared to be here in the sky. When I was over here on Earth, star A appeared to be here. What kind of difference is that in terms of my vision? Now, truthfully, in science and everything, we would use degrees, and we could get into some really interesting measurements. We're not really as interested in the measurements as we are in understanding the idea behind it. So let's take a look. Here's star A, and the difference in where we've seen it in our drawing, the direction said go 1 inch from star A and measure this distance. And this person got, okay, this is 6/16 of an inch on this drawing. Let's go to star B. We do the same thing. We drew a line through star B. That was our vision of star B. Over here, here's where star B appears to be. On our drawing, to give us some information, we go down an inch and we say, well, how much difference was that in our vision? And on this image, it's 3/16. So let's take a look at what that means. Star A is obviously closer to both the Earth and the Sun. We see that on our image. Star B is farther away. So the question becomes, which one had the most dramatic shift in our view from Earth? Was it the star that was closer, star A, or the star that was farther, star B? So the reason I wanted to review this is, number one, this was something you were asked to do to help you visualize what the main concept is in the parallax view. The parallax view is the name of this shift, and we use it to be able to determine which stars are closer to us and which stars are farther away. So now I'm going to scroll down here. So using that information, we're going to look at it as if we're looking up into the sky. So here are the directions, very much like what we did on our little sort of image, our pretend image. It says here are two different stars, ABBA and BABA. We look at we look up in January and we mark it, and we look up in July, 6 months apart. And we notice that star ABBA has this much of a shift between these two purple pictures of the stars. BABA has this much of a shift. So now, using the concept that we thought about and we used in our image, which star must be closer, and how do you know that? Then here's a further question to sort of really solidify that. And it says, okay, we're going to pretend now that ABBA has 2 times of a shift or parallax angle compared to BABA. Say this is 4 degrees of shift and this is 2 degrees of shift. What do we know about the distances of the stars? Just the relative distance. Which one is farther? Which one is shorter? Can we make any guesses as to how much farther and how much shorter?